Good afternoon, class. So at this point we're looking at trigonometry problem solving in 2 and 3 dimensions. A couple of weeks ago, or a week ago I think it was, or could be a couple of weeks ago, 2 weeks ago, yes. We have started this topic and I got no response from you, okay. So, I gave you a chance to revise the grade 11 sine, cos and area rule. Okay, I hope you did it. So let's try again. So now we're looking at trigonometry problem solving in 2 and 3 dimensions. At this point we already spoke about, or you refreshed your memory what sine, cos and tan stands for. It's, in that case for sine, cos and tan only dealt with in right angle triangles. And if it's for angle A, that is your opposite. If it's angle B, that is your opposite. However, your hypotenuse remains your hypotenuse. This was the study you had to do as the sine rule. And the sine rule says that A over sine A is equal to B over sine B, which is equal to C over sine C. Whilst the cosine rule is going to be A squared is equal to B squared plus C squared minus 2BC cos of A. When do we use the sine rule and when do we use the cos rule? We use the sine rule if 2 angles and a side is given. However, the cos rule can be used only when the included angle of 2 sides are given, or 2 sides and included angle is given. Okay? The derivation can be taken from, if you want to memorize it, you can. But I'm sure at this point you guys can manipulate the formula and make whatever you want the subject of the formula. Okay. Then a refresher is given with regards to the angle of elevation and the angle of depression. The angle of elevation is the angle that rises from the horizontal and declines from the horizontal. The angle that goes down is depression, while the angle that going up is elevation from this point. Then the area rule. And also we know that the angle of depression is alternate to the angle of elevation. The 2 angles are equal there. Okay? The area rule, that is in a non-right angle triangle, is that it's going to be a half AB sine C, depending which angle is known. For the area rule, it will be 2 sides and an included angle. Now we have example 1 on page 212. Example on page 212. So here we are told that X is just behind the calculator there. Okay. So we are told that in triangle PQS, we are told that R is the midpoint. So if R is the midpoint, as you can see here, then that length is equal to that length. It's already marked on the diagram as well. Then we are told that QR is equal to RP, which is equal to RS, which is equal to D. So all of that are D's there. Then PS is A. Then we are told that PQR is theta. The question says you must prove that angle or A is equal to double D or twice D sine theta. Okay? So how are we going to do that? There's one of 2 ways that we can do this. We can always start off with what is the subject of the formula. Makes it a bit easier. Okay? So, if we're looking at A, there's a triangle A would form it, and there's a triangle that A would form. That's all. But if you're looking at the big triangle, remember here's a D here, and there's a D here. I can calculate this angle here. Not so? There's theta. This will be 2 theta. Exterior angle is equal to sum of 2 interior opposite angles. So which triangle do you think we're going to work in? Sorry? P? PRS. Okay? We have two lengths and an included angle. So which rule? Cos rule. Can we use a sine rule there? No, we won't be able to use a sine rule. Okay. So firstly, let's lay the working out. So firstly, we're saying that Q P R is equal to theta. And why is that the case? It's angles opposite equal sides. Not so. Then we say that angle is going to be 2 theta. So PRS is equal to 2 theta. Why? Exterior angle of triangle. And it's triangle PRS. Okay? Remember, this is already given D and D. So I don't have to state that because right there it's clear, it's given. Okay? So now we can say that A squared is equal to what? D squared plus D squared minus 2D times D cos of angle 2 theta. Okay? So D squared plus D squared is 2D squared minus 2D squared cos 2 theta. Now looking at what we have opposed to what we must end up with, what do you notice? They have a sine. So where do you think the sine is going to fit in? With a cos double angle. Not so. So cos 2 theta is equal to 1 minus 2 sine squared theta. So I'm going to replace that. So it's going to be 2d squared minus 2d squared into 1 minus 2 sine squared theta. So what do I do now is get rid of the brackets, multiplying. Which now gives us 2d squared minus 2d squared plus 4d squared sine squared theta. So what happens now? What happens now, people? You can cancel. So this cancels. Leaves you with a squared being 4d squared sine squared theta. Now what? Square root. Normally when you go square root, it's plus minus. But length can't be negative here. So therefore, a is equal to square root of 4 is 2. Square root of d squared is d sine theta. And we have proven what they were looking for. So for homework, I want you guys to do exercise 1. This is on page 121. You do for me the odd numbers, okay? Exercise 1, page 121, the odd numbers. You guys finish? Still writing? Okay, so there are your 3 sums for tomorrow. So now we're going to look at 3D problems. Problems in 3 dimensions. I want you guys to write this note down. We're going to go through them now. You all see? So make it a bit bigger. Alright. So problems in 3 dimensions. So problems in 3 dimensions. 3-dimensional problems can be complex because you are working in 2 planes, namely your vertical and your horizontal plane. So your vertical, if they're talking about your horizontal plane, always think about the ground. Okay, the ground is in the horizontal, and something that stands up straight is your of course your vertical. Okay, or your walls, whatever. Right angles do not always look like right angles, as you can see here. This is a right angle triangle. But because it's on a slant, it doesn't look like this is a right angle, but it is. As long as this is your horizontal, this is your ground, and this is your something standing up straight, vertical, that will always be 90. Can you see that, people? Likewise, that is also 90. Okay, even in the second figure, that is your vertical, that is your horizontal. Is your ground, like in other words. Your vertical will always stand 90 degrees to your horizontal. Okay? That's so hence that's telling us that it doesn't always look 90, but it is given 90. Okay? Horizontal is perpendicular to the vertical. The diagrams below represents 2 typical 3-dimensional diagrams, where AB is the vertical height and B, C and D are in the same horizontal plane. You will read that often, it's in the same horizontal plane, which, as I indicated, consider to be the ground. The horizontal plane is shaded, and they're telling you which angles are 90 degrees there, as I indicated it earlier. Okay. Now we're looking at the example 1 on page 125. So example 1 on page 125, we are told that Sheila and Desmond stand some distance away from building AB. Okay? So Sheila is marked with C and Desmond with D. Okay. And we are told that as a height of 12 meters. So we know that the height of the building is 12 meters. The foot of the building, the foot is basically the bottom part of the building. Okay? The foot of the building, B, Sheila and Desmond are in the same horizontal plane. So what do we assume that to be? They are all on the ground. Not so? The foot of the building is on the ground. Sheila and Desmond is also standing on the ground. That is why they say the same horizontal plane. Okay. The angle of elevation from D to the top of the building A, from D to the top of the building A, is 40 degrees. You all okay with that? Then, from C to A is 45. See the angle here is 45 degrees. Then we are told that CBD is 55 degrees. Now, CBD is on the ground now. That is 55 degrees. Okay. The question is calculate the distance between Desmond and Sheila. Okay? In other words, they want you to work out that distance. Not so? So if you look at this, there's many triangles. Okay, to calculate C, this length between Sheila and Desmond, if I know what BD is, and I know what BC is, if I know what that is, I then can calculate CD how How can you calculate CD, the length of CD? Why didn't people go learn the sine, cos and area rule? Who went and go learn it? Who did all the exercises? None of you. Sad. You're going to use the cos rule, okay? So what you should note here is that in triangle ABD, I'm going and calculating BD. In this triangle, that is going to stand 90. So what I'm going to do is, I'm going to draw the triangles. Okay, so that is B, A. You don't have to draw it, but that's what I have in that triangle. I'm going to calculate BD by using opposite and adjacent, which is tan. So I say tan of 40 equals opposite, which is 12, over adjacent, which is BD. That's over 1, so I cross multiply. So BD tan 40 is equal to 12 divided by tan 40. So it's going to be 12 over tan 40. So BD is 12 over tan 40. So what I'm going to do is I'm going to put that in the calculator. So it's going to be 12 over tan 40. That gives us 14,3. Okay. Then I do the same with triangle ABC. So I'm going to take this off because I need the space. So in triangle ABC. Again, you don't have to draw this, but this is what you should be seeing. That is 90 now. Why? Because the horizontal is perpendicular to the vertical. It's ABC. I'm calculating BC, that is 12, and this angle now is 45. Which trigonometric function? Again, tan. So tan of 45 equals opposite over adjacent, cross multiply. So BC tan 45 is equal to 12 divided by tan 45. I will have tan 12 over tan 45. That gives me 12. Okay. So for this triangle on the floor now, or in the same horizontal plane, I can now apply the cos rule. Again, I need the space here. So according to the cos rule in triangle BDC, we have a triangle looking like this now. That is 55 BDC. That is 12 and 14 common. Two lengths and included angles, the cos rule. So DC squared is equal to 12 squared plus 14 comma 3 squared minus 2 times 12 times 14 comma 3 cos of angle 55. So DC squared is going to be 12 squared plus the last answer calculated was 12. So it's 12 squared plus 14.3 squared minus 2 times 12 times 14.3 cos of 55. That gives me 151.64. 151.64. The root thereof gives me a distance of 12.31 meters. Okay. You're looking at the work example 2. So page 126, you're looking at example 2. We are told that the figure shows a cube. So what is a cube? A cube is a prism with all sides or all lengths of the same value. Okay, all the edges are the same lengths. Okay. The length, the breadth and the height is all the same value. It's a cube. With sides 20. So all of this is 20. 20, 20, 20, 20. Okay. You guys get the idea, no? All lengths being 20 millimeters. The question is calculate the angle that the plane BRS makes with plane. So AB RS. The angle the plane ABRS makes with plane ABCD. So if you're looking at ABCD, it's basically the plane on the floor. Can you see that? So the angle that they are actually wanting you to calculate is this angle. Okay? Alright, so to get that angle out, this is 20 and that is 20. This angle there is 90. Why? Because your horizontal stands 90 degrees to your vertical. So if that is 20, so you got a triangle looking like this, 20, 20, 90. The theta angle there. So if this is theta, that angle on top is also theta. Why? Because the isosceles triangle. So therefore theta will be 45. Okay. This is BRC. Okay. In question 1.2, they ask you to calculate the diagonals BS makes with plane ABCD. So in other words, they want you to work out this angle. Let's call that angle beta for now. Okay? So if we look at this triangle here, a triangle is formed there. I'm going to draw it here to show you what it looks like. So it's B, you got S, D, B. So what can be calculated here? I can calculate. We know what SD is. What is SD? Okay, I'll tell you, it's 20. Now looking at the BD. BD can also be calculated. Can you see that? BD is from a, what type of shape is this? It's a square. Okay? So this a DCBA. What is the length of the side here? 20, yeah? 20. So DB is that line going through like. Okay. So remember that stands 90 degrees there. So DB is your hypotenuse in that triangle. Not so? So D B squared is equal to 20 squared plus 20 squared, which is 400, 800, the root thereof, maybe something root 2, 20 root 2. Root 2. Okay, which is this length here. So as you can see, that is enough information then to calculate that angle marked beta there. How do we do that? By saying that it's going to be your opposite over adjacent. Which trigonometric function uses opposite and adjacent? Lekker, sine. Tan is opposite over adjacent. So beta is equal to arctan of 1 over root 2. The 20s will cancel. So arctan of 1 over root 2, it gives you 35,26. .26 would be the size of angle beta marked there in the diagram, okay, which is the diagonal is B that it makes with the horizontal with the plane ABCD, okay. For homework is exercise 3. You do the odd numbers for me, okay? So what I'm going to do is I'm going to do another sum. I'm going to do 2 even sums here, even numbers, out of exercise 3, okay? First cut the odd numbers. People, this section in paper 2 is worth 10 marks. I actually feel cheated on now that you guys didn't even bother to go learn that work that I gave you time to actually go learn. Sad. Very sad. Let's look at number 2 out of exercise 3. Which page is this on? Exercise 2 on page 136. 26. So here we are told that the figure represents a triangle, a triangular prism, with AB equals AC, which is equal to 10. So AB is equal to AC, which is equal to 10. Just by looking at that, you should be able to tell me that, if you have done your homework, you should have been able to tell me that you can calculate BC. Why? Because it's a constant. So the question says that BAC is 70, which is this angle here. Okay. Calculate the area of triangle ABC. So how do you calculate the area? We need two sides and included angle, which we do have. Two sides and included angle. So the sine rule is going, the area is going to be half AB sine C. So it's going to be AB times AC is the two lengths, and you included angle, which is going to be sine of 70, which is ABC. Okay, which is going to be half times 10 times 10 times sine of 70. Okay, put that in a calculator. Make sure the D's on the calculator is in degrees. So it's 10 times 10 times sine 70. It's going to give you 46,98. So it's 46,98 centimeters squared. Okay. Let's look at 2.2. In question 2.2, it says calculate the length of BC. And that's what I've indicated there earlier on. So we're going to use the cos rule. So CB squared is equal to AB squared plus AC squared minus 2 AB times AC cos of angle BAC. Do I have to write this out first before I do the calculation? No, there's no mark indicated for this. But just in case somebody else might come across the video, not you guys, somebody else, and they are a bit confused, they can see where it's coming from. Okay? So AB is going to be 10, so it's 10 squared plus 10 squared minus 2 times 10 times 10 cos of angle 70. So you put again on the calculator, 10 squared plus 10 squared minus 2 times 10 times 10 cos of 70. As it's the cos rule, is 131,59. The square root thereof gives you 11,47. So BC is going to be 11,47. centimeters. Okay, so we put here. Okay, so in 2.3, the question is to calculate the height of CF. So if you look at what we have, again I forgot to draw the diagram, the triangle for the other diagram, but it was fairly clear for 2.2. So what we have here is B with 40 degrees there, and CF. The question says calculate the height CF of the prism if angle CBF is 40. But remember, we got that to be 11,47. So which trigonometric function uses opposite and adjacent? It's tan. So we say tan of 40 equals opposite, which is CF, over your adjacent, which is 11,47. That's over 1, so we cross multiply, so CF is equal to 11,47 tan of 40 degrees. That's going to give us 11,47 tan 40. That gives us 9,62. 9,62 centimeters, as they're referring to the units there to be centimeters. Okay, the sum is worth probably 4, 7, 8 marks. That was number 2. Let's look at number 6. So number 4. Let's try number 4 first. Okay, let me give you a chance to do number 4. Before I answer it. Pause the video at this point. Okay, so that basically marks the end of the lesson.
Emma Rose Bebe and Kiara Johnson, can you please report to the office? Emma Rose Bebe and Kiara Johnson, please report to the office.
Okay, good afternoon, class.